Hello, hello, and good evening, everyone. My name is Jacqueline Stallman. I'm the manager of public programs at the Walker Arts Center in Minneapolis, Minnesota. Since its inception, the Walker has hosted talks by artists, writers, and other great thinkers whose insights and ideas have informed our world. The Mack Lecture Series explores our culture and contemporary moment through inspiring conversations and lectures aimed to deepen our understanding and appreciation of the great thought leaders of our time. Tonight's program is no exception. The Mack Lecture Series is made possible by generous support from Aaron and Carol Mack. So thank you for your support. We are so pleased to present tonight at long last a conversation with theater director Annie Dorsen, AI researcher and professor Zachary Chase Lipton, and Radiolab producer Simon Adler. This conversation was originally scheduled for April 2020 and was canceled for reasons we are all too familiar with at this point. Along with the talk, Annie Dorsen's work was originally scheduled to show that previous March and was also canceled. We are so pleased to host this conversation tonight and hope that someday in the very near future, we might all be in the McGuire Theater together enjoying Annie's work in person. Until then, we're grateful to host this conversation for you, taking a deep dive into Annie's practice and to learn how artificial intelligence takes center stage in her work. I'm going to introduce two of our speakers tonight, and then I'm going to welcome my colleague, Philip Either, Director and Senior Curator of Performing Arts, to introduce Annie Dorsen and speak to her performances planned in the future. Zachary Chase Lipton is the BP Junior Chair Assistant Professor of Operations, Research, and Machine Learning at Carnegie Mellon University and a visiting scientist at Amazon AI. His research spans core machine learning methods and their social impact, and addresses diverse application areas, including clinical medicine and natural language processing. Current research focuses include robustness under distribution shift, breast cancer screening, the effective and equitable allocation of organs, and the intersection of causal thinking and the messy, high-dimensional data that characterizes modern deep learning applications. Moderating our conversation tonight is Simon Adler. Simon is a reporter and producer with WNYC's Peabody Award-winning podcast, Radiolab. He's reported stories from 4 continents on not on 4 different topics, on many different topics, ranging from professional wrestling to Caribbean raccoons, with a particular focus on the intersection of technology and authenticity. Now I'll turn it over to my colleague Philip to introduce our artists tonight.
Hi, Jackie. Thanks so much. And it's a pleasure to be with you all. Especially, I want to say thanks to Annie Dorsen for doing this talk tonight. She's one of the most inventive and engaging theater artists of our time. A director and writer whose works explore the intersection of algorithms and live performance. Her most recent project, Infinite Sun, is an algorithmic sound installation commissioned by the Sharjah Biennial 14. And some of her previous performance projects include The Slow Room, which the Walker was lucky enough to be a co-commissioner of, which premiered in 2018 in New York. The Great Outdoors from 2017, A Piece of Work, 2013, and Hello, Hi There in 2010. All of those have received critical attention and have presented in different cities across the US and around the world. Annie was the co-creator and director of the influential musical Passing Strange, which opened on Broadway in 2008 and was made into a film by Spike Lee in 2009. In addition to these, the critical acclaim and tours, Annie's received such top awards as the 2018 Guggenheim Fellowship, the 2018 Spalding Gray Award, and just last year, the much coveted MacArthur Fellowship Award, better known as the Genius Award. I have followed Annie's work for more than a decade, and I am really thrilled to be able to let you all know that after 2 postponements, as Jackie mentioned, we are determined to bring her wonderful 2015 work, Yesterday, Tomorrow, to the Walker exactly 1 year from now this week. So I hope you join us live for that. And would you please welcome Zach, Simon, and Annie Dorsen.
All right. Thank you, everyone, for being here. I can't see you, but apparently you can all see us, so that's exciting. This morning, as I was thinking about tonight and this event, I started to wonder just how much artificial intelligence I interact with on a regular day. And so as I moved through today, I actually started counting for myself. So scrolling through my Facebook, one tick. Several emails I sent, I had autocomplete sort of finishes the sentences for me. I was on a website that had a customer service chat pop up. This is just 3. I'm sure there were many more that happened that I wasn't even aware of. And anyhow, it just reminded me how we're interfacing with these technologies constantly and oftentimes unknowingly. I mean, right now at this moment, well, we're all here virtually staring at our screens, and they're renderings of our flesh and bone and human intelligence. Underneath it all, invisible to us, are just untold processes and products facilitating this moment, many of which deserve the label of artificial intelligence. I think our relationship to these technologies and their relationships with us, how they're feeding back on us, changing us in subtle and not so subtle ways, truly is one of the defining dynamics of our moment. And few people have explored these dynamics as deeply or as thoughtfully as the 2 folks I'm so lucky to be sharing the screen with here this evening. And well, I'm really excited to dive into some of the depths with them. Before we do so, Annie, Zach, I think we should take a quick beat to just define 3 simple definitions of some key pieces of terminology. So Annie, let's start with you. We've heard this term artificial intelligence thrown out innumerable times. I've probably used it 7 times already this evening. In your world, in your work, what the hell does it actually mean?
I mean, it's such in the way that phrase is like such a catch-all for so many different kinds of things. And the use of it, I think, goes back, far, far into the sort of beginning of the 20th century. When we talk about it in general, I think we're talking about sort of like technological means to imitate the process of thought or consciousness. Okay. But Zach, I would love you to correct me when I say things wrong, because, I'm not a technologist. So I approach these things like my research is really as an artist trying to understand things, not as somebody who really works with the material. But, so we can think about like contemporary AI, we tend to think about machine learning processes or deep learning. But the phrase itself, I think, can be a much broader, has like a much broader overall definition, which includes a lot of things that we don't think of necessarily as very intelligent, like chatbots, like the kind I used in Hello, Hi There. Don't seem very intelligent at all, but we're an early effort at artificial intelligence.
Got it. Okay, well, and so you've already used what my second term is, and Zach will go to you for this one.
Yeah,
but machine learning. Or go ahead, take it where you want.
Yeah, I think just a perspective there is, it's definitely, I think Annie kind of pointed out how it's sort of this heavily overloaded term, both overloaded maybe in different meanings and connotations, but also ascribed by many different communities. I think there's like a popular cinematic idea of what AI is. There's the sort of etymologic kind of, if you want to trace, if you're a bit originalist about like language, you could say, well, there's a particular school of building intelligent systems, which is there's like the school of John McCarthy and these people emerging from a convention in 1955, I believe, that coined the term AI to refer to this sort of like symbolic logic sort of approach to systems, as opposed to like the sorts of things that the cyberneticists were interested in. And now we're using the term AI to refer to a broader set of technologies that includes the things that really are ideas that originated with the cyberneticists. So like when I teach classes and I sort of try to situate these terms, the definition that I like is, I think, a working definition that maybe is what most of us in, like, say, the research community, I think, have adopted as a sort of consensus. And I'm kind of paraphrasing actually a former department head or dean of computer science at CMU here. A definition that I like is that it's the science and engineering of building systems that sort of perform behavior that we thought until recently thought required human intelligence. So what I like about the definition is it captures the fact that it's a science, but it's an applied science. It's not only concerned with the theory of cognitive science, but actually or the statistical theory of systems, but actually of building systems that actually work. And that also that it's a bit of a moving target. That I think, when we first had adding machines, everyone thought, well, this is replacing the work of, say, various sorts of human clerical work. And so, there was this sort of sense of them being very anthropomorphic. And now we don't think of the calculator as a great threat on the human turf, but we do think of, for example, really high level, say, machine translation as being that. If I could just maybe segue into machine learning then.
Yeah, please.
Machine learning is specifically the sort of science of building systems that learn in the sense that they improve, usually at some very well-defined task with respect to some very well-defined metric, as a function of experience. And experience in the most common systems, which are, say, prediction machines, just constitutes exposure to data. So, for example, we don't know how to build a system that would classify images as depicting, do they recognize, does an image depict a dog or a cat or a horse or a zebra or whatever? But we know how to build a flexible sort of program such that if we give it many examples, here's an image and here's the label, here's an image, here's the label, it'll get more and more accurate as you present it with more and more data. So systems that have that flavor. So if you look at AI systems, for example, that played chess, that beat Garry Kasparov, there was no learning involved. If you played the system, you ran that program today, and then you ran it, a million times, and you ran it again, it's going to behave the same way. It was sort of coded a priori to perform a certain kind of exhaustive tree search as far as it could go, and then to use some kind of heuristic to evaluate the positions, back everything back up, take a move. But a translation system is actually presented with more and more and more data, and as you keep presenting it with more and more data, data being basically say here's a sentence in English and here's the corresponding sentence that is a valid translation in French. It'll actually keep getting better and better and better, and it's because it's a very flexible sort of program that's able to fit the data. So it's you could think of this as the intersection of computer science and statistics, that we have systems that are learning from data. There are times in history where the dominant AI systems had very little to do with learning, but I think we're at a moment right now where most of what people call AI, or at least is sort of headline grabbing AI in the last few years, belongs to machine learning.
Okay, so we've got AI, which is computers or systems being able to execute upon tasks that once we thought were human, and then machine learning is specifically a subset of those processes that are getting better over time, sort of teaching themselves in some way. And then I guess the last one here that I think we should hit is just algorithm. Again, we hear it all the time. We hear about the Facebook algorithm, but again, and I'll leave it to either of you who'd like to take a stab at that one in sort of so that a seventh grader could understand it. What the heck is an algorithm?
Right. Well, an algorithm is really simply just a set of steps or instructions. It's like a recipe, right? So, an algorithm, in the sort of first year of computer science class, you would learn that an algorithm doesn't have to be on a computer. An algorithm can be just any set of instructions, famously the recipe to make a cake or directions from your house to the airport. If you break that down into discrete steps, you do this, then you do this, then you do this, then you do this, that kind of counts as an algorithm. So obviously, computational algorithms can be much more complex than that, can have many different kinds of instructions going on that affect each other, and can be so complex, in fact, that humans have a very hard time to supervise them or even really understand exactly what they're doing at every step along the way. But essentially, it just means you have some kind of an input, you follow a certain set of instructions, and it spits out an output.
Got it. Okay, well, so with that business out of the way, well, let's stick with the word algorithm here, because Annie, this field that you have pioneered is that of algorithmic theater. And before I ask you a specific question about it, I'll say that when I think of going to the theater, I expect to see a set of characters inhabiting a story of some sort with a beginning, a middle, and an end. And as I've watched much of your work, on the surface, I don't see those things. But I believe they're there. So let's dive into one of your works from 2010. Hello, hi there. And I think we have a little image of it that we can pull up, but help me. It'd be so lovely if we were all in the same room in a theater watching this piece. But put me in that seat, if you would. What I'm looking up at the stage, and what am I seeing?
Okay, so with Hello, Hi There, I sort of made a piece for 2 chatbots, and a chatbot, C-H-A-T, like chatting, is a kind of like, it's, like a bot is like a robot with no body, right? It's a little piece of software, a little piece of code that does something. And a chatbot is a little piece of code that produces chit chat, basically. It's like a really basic form of natural language programming, which is the sort of branch of computer science that's about trying to imitate like normal conversational speech. Okay. So in this piece, I have 2 chatbots that are generating, or improvising in a way, a new conversation at every performance. And they're talking about another conversation. So I started this piece thinking about the debate from the early 70s between Noam Chomsky and Michel Foucault. This was a debate on Dutch television. It was super well known at the time, in the 70s, and it was.
Well, and those guys weren't that smart, so it'd be easy to program a chatbot to be able to talk about what they're talking about, right?
Right, precisely, yeah. But in some ways, actually, I mean, that debate, so one of the things that they're talking about is the relationship between language and sort of creativity and consciousness.
Okay.
Many have noted in reading that debate or in watching the video of it that in a way, nothing really new is produced by their conversation, that they each have a position. Okay. And they kind of say what they were already thinking and what they were already going to say. And that it doesn't really do what great conversation should do, which is like give rise to new thinking or something that, somebody didn't express that way before. Very briefly, without going into it, Chomsky's position is that language is a kind of great carrier for thought. Like the way this all works is that you think something, you put it into words, you say those words, the person you're talking to hears them and they understand the thought, kind of a Platonic notion of how language and thought works. And Foucault, on the other hand, says, no, really, the relationship is way more complicated than that. And I'm not sure that we really think new thoughts that we then put into words, but maybe we're more repeating things that we've heard, so that we're kind of not so much producing original creative thought, but we're kind of repeating the thought that exists sort of out there in society, right?
I see a connection here between that and these little chatbots you're about to be working with.
Yes, exactly. So I wanted to work with this debate, and a friend of mine suggested that I look at a very famous essay by Alan Turing, in which he sort of proposes the idea behind chatbots and says, we don't really know what thinking is. We don't know how it's done. So how could we possibly create it in a machine? What we could maybe accomplish is to create the impression of thinking or the effect of thinking. And so when I read this and I started playing with some little online chatbots, I thought, well, this is theater. I mean, it's really about using language to create a kind of belief in an audience or an effect. So that's where the idea kind of came from, to see if I could program or work with a programmer to fashion a chatbot or 2 chatbots that could sort of do the same kind of conversation that Chomsky and Foucault had. They wouldn't repeat what Chomsky and Foucault had said. They would try to invent new thinking together.
Okay, well, and if they're trying to invent new thinking together, clearly they're doing it. They're more of the Foucaultian school of thought here, where they're just taking information that's already been input into them and spitting it back out, I would presume. Zach, is that how a chatbot, how the heck does a chatbot work? Because how does one computer know how to respond to another computer? Or Annie, but whoever wants to take this.
Just before Zach answers, these are dumb chatbots. This piece, I made it in 2009. It premiered in 2010. Okay. So a lot actually has happened in this field since then. Okay. But at that time, the technology was like pretty rickety. You could say it was pretty old-fashioned in a way. Like, so just to not lead Zach astray, have him start talking about things much more sophisticated than I did.
Understood. And before I go to you, Zach, I will say that if folks in the audience haven't watched it, there are versions or clips of it online. And I will say it is pretty, you call them rickety, but these computers are having conversations with one another. They're talking about dating, and they're like who they would be as like a person on the internet. I don't know if it's quite uncanny, but it's borderline uncanny. But Zach, how the heck does one make something that can do that?
Big I guess I'm trying to think of the right way to. I mean, I should say a priori at the outset that one thing that I can't speak to, and that I think is maybe part of one of the things that's kind of fascinating from my perspective of checking out some of Annie's work in advance of here, is that even being a technologist, it's not always immediately obvious to me watching the works what precisely is the implementation, behind the scenes, and how exactly are things working. I can speak generally that, there's sort of maybe a bit of, in general, like when you approach problems computationally, a bit of like a modularization between like the kind of problem you're attacking and the methodology that you're using to attack it. And so,
Zach, I'm sorry, I'm going to have to interrupt you because I have no idea what the sentence you just said means.
Sorry, sorry, I didn't think that was the jargony one. There's a bit of a separation between like what is the task and what is the method, right? So like, yes. For example, before, like my example, like you want to predict is you wanted to classify images. Do they depict cats versus dogs? So that's an example of a task. But then you say, how do we go about that? Well, one approach is somebody looks at a bunch of pictures of cats and dogs, and they come up with a bunch of rules. And they say, if any of these rules fire, it's a cat, otherwise it's a dog. Another way is somebody says, I'm going to assume that there exists some set of weights such that I take a weighted sum of the pixel values. And if it's greater than 0, it's a cat. If it's less than 0, it's a dog. Okay. Another person comes out and says, I'm going to have this decision tree, and it's going to go through some other process. So there's a lot of different methods. So the idea of building computer systems that can pass as some kind of interlocutors has been around for a while and has been approached with a lot of different technology. So, I mean, you have everything from sort of template type systems where maybe there's some sort of rule, like, and if somebody mentioned, like early systems like the Eliza system, which I think is the sort of inspiration for a lot of chit chats, came out of, I think, I believe out of MIT, out of in, I don't know, the 60s, 70s, maybe, was, a system that sort of engaged in sort of open-ended dialogue, and it could tell that someone was speaking about an emotion. So it says, tell me how that makes you feel, or, and it had certain cues. When you hear this cue, fire something, in this template. Now, a lot of the systems use machine learning. So a lot of people, just like sort of the whole of the field of AI is shifting towards machine learning. A lot of what people try to do now is come up with things like massive corpora, where you have examples of dialogue, and then to do something like where you kind of the way you would train a machine translation system. So the way they train these systems, by the way, is like you're given your sentence in, say, English, they'll say, try to predict what the first word of the French translation would be. And then you say, okay, given that you got the first word right, try to predict what the second word would be. And at training time, you actually know what the ground truth first word was and second word and third word was. You could actually, condition upon the, having gotten the first so many words right. And each word, you're just trying to generate one word at a time.
Got it.
You could also, that's not limited to trying to do translation. You could also just, instead of actually what you had was, English sentence, French sentence pairs, you could have a data set consisting of, for example, dialogue from movie scripts or dialogue from, NPR interviews or whatever it is. And so then you could basically say, instead of trying to predict the translation from in the target language, from the source language, you say, my goal is I want to predict the response from the prompt. So, I have like, basically here's, speaker A, try to predict what speaker B will say. Given what speaker B said, try to predict what speaker A will say, or even condition upon some longer amount of history. So, I mean, I would defer to Annie for answering any kind of specific questions about what's at work in this or in future works that she has planned, but maybe that gives some context on how some of these systems have sort of evolved over time.
Right. Yeah. So we don't do any of that. Hello, hi there. So one little, part of this is that I come from a theater background, and I kind of, as I said, sort of accidentally fell into this area of work, kind of based from like back to that friend of mine, Joanna Bailey, the composer, giving me Alan Turing's essay and saying, maybe you should read this, and that was, so I, learned as I was making pieces. And the first piece, Hello, Hi There, that I made in this vein is the dumbest possible thing you can imagine. It's like so far from being magical or cool on the level of the technology. Like it is a glorified Eliza. And Eliza is like this sort of super famous, like the first chatbot that Joseph Weizenbaum made, and I think it was in 1965 or 6 at Bell Labs in MIT. And he programmed this thing basically with a very short script that it would follow. It was meant to talk to a human, right? So the human would sit there at the computer terminal and would say, oh, I don't feel so good today. And the Eliza chatbot would say, why don't you feel so good today? Right, so like very simple kind of substituting, turning a sentence into a question, those kinds of things, repeating, what was said to it. And the Hello, Hi There chat has a finite database of language that I painstakingly input myself and like connected everything sort of together and made like this massive kind of like rhizomatic structure where there are mathematically potentially like billions of different paths that the chatbots could take through the database, but they're not inventing anything new, and they're not using any predictive technology whatsoever. They're kind of like rolling the dice about whether my answer to this question is going to be this or this or this. And they've chosen something that becomes the new input for the other chatbot to pick from a list of possible responses. So it is like dumb, but I will say it does, occasionally produce, and then we did like a lot of theater stuff to it also. We like added different, randomization of different pause lengths, and we did some lighting stuff, we sort of dressed it up a little bit.
Got it.
Oh, sorry.
No, go ahead.
I just read a kind of like popular history. It's called A Brief History of Artificial Intelligence. No idea where they got that title idea. By Mike Woolridge, who's a CS professor at Oxford. And we did an interview together. And so in prep, I read his book. And he talks about the Eliza system. And I guess like the rumor is that like, I don't know if it's apocryphal, that like MIT PhD students would stay up at night, talking to Eliza because it was so engaging to them. But
I believe it was his secretary, actually. Who,
but I don't know if this says, more about the intelligence of Eliza or the lack of social intelligence of computer scientists.
Well, I think, actually, there's some interesting stuff in that story. Like Weizenbaum later, I think in the mid-70s, he really got kind of pissed off at how credulous people were in the face of these machines. And he thought, this is really a disaster, because what we didn't want to do, or what he says he didn't want to do, was like trick people.
Sure. Well, this is like a funny, like recurring theme in artificial intelligence, which is researchers at once being annoyed at the public for being credulous or kind of gullible, and at the same time being guilty of overselling their technology.
Absolutely, exactly. I mean, we're seeing a lot of the same kinds of, under and overselling claims coming out of Silicon Valley now. But one of the things, that I think this like Eliza effect, what people call the Eliza effect, which is that even in the face of like a very stupid technology, you as the human person interacting with it can like supply what's missing and invest in it and sort of believe in it. So you take, very little evidence and sort of flesh it out until it becomes something that you can, like that you sort of ascribe to it much more sophistication than it actually has.
Well, I may have been a victim without watching it.
No, sorry. Ask Annie. Could I ask a question about the piece actually?
Yeah.
So you're leaving something up to chance, because there are these moments where there truly is some random process choosing what to say. And at the same time, like, you have quite a bit of agency, right? Because you are setting you're setting the landscape of possibilities. Like, it's choosing among the script or the options, but you've created the options. And I guess, how do you think about like that balance of how much you leave to chance and how much is designed and is your agency, and sort of just like what does sort of like the artistic significance of that choice?
Right. So you know, like it's a really great question, and I tend to call what I do like sort of collaborations with computers rather than you know, what you'd call like real tech research. You know, like, I'm normally engaged in a process of research as I develop a project, but then by the time it's turning into something, it's a back and forth where I make a lot of decisions and then I leave a lot up to the algorithm. But, you know, maybe the algorithm starts doing things I don't really think are that interesting. So I go back, we tweak the algorithm, rewrite parts of it, see if we give it a little nudge, you know, to make it sort of more consistently interesting. And there's this like super long tradition of that in the arts. I mean, in a way, what I've been doing is not so radical if you think about the history of contemporary music, or a lot of you know, computer-generated visual art, dance, certainly. You know, all of those fields have a very strong tradition of like rules-based composition. So the big person, you know, who sort of hovers over all of that is John Cage. And I was, you know, it's not an accident that I did like this complete, like, giant self-study of Cage's work, you know, just in the immediate years before starting Hello, Hi There. And one of the questions I always had was like, how can I apply those principles in a way to theater? Given that Cage's own experiments in doing that were not, in my view, like super artistically successful. They were very interesting.
Okay.
So, you know, when we talk about this, like, you know, John Cage would set certain parameters and then he would leave a lot up to chance, and he called his work chance operations, emphasizing the chance aspect. But if you think that what his real, like, you know, artistic contribution was, in a way, it was the establishing of the parameters. And another way you can talk about those parameters is as an algorithm. Those are the rules. That's the range of possible options. What was the process of, you know, composition that went into those pieces?
Interesting. Well, let's bring some humans into the equation here and fast forward through time from 2010 to, I believe, 2015. Your piece Yesterday, Tomorrow. Again, I think we have an image of it again, but if you could, like, what the heck's going on in this thing? We have 3 people on stage. There are a variety of screens. There's sort of a cube that everyone's in, a 3-sided cube. And what's happening? What would we be watching?
Right. So the piece is sung by 3 vocalists. It's a song through. And it's very simple, kind of high concept thing where we start with the song Yesterday, and then slowly the lyrics and the pitches of the notes and the durations of the notes are all morphing bit by bit into the song Tomorrow from the musical Annie. So it's a like migration process where you start out hearing a song that's incredibly familiar, you know, sentimental, we all know it by heart. And then as the notes start moving, you enter into like a kind of a no man's land where, you know, you sort of lose the melody of Yesterday at one point. At a certain point, all the lyrics turn into gibberish. And then slowly again, like, you start to hear something familiar, and the new familiar thing kind of emerges from the morass. And eventually you land in Tomorrow, which is also indeed like a sort of an over familiar tune.
Right. Well, and so what sort of ideas, or what was the metamorphosis of your practice or your thinking that took you from chatbots having a conversation with each other about Foucault and Chomsky to having people sing 3 people sing 2 very popular tunes? Yeah. What's the through line here?
Yeah, right. So, like, you know, Hello, Hi There, I mentioned like, I sort of accidentally had this content of the Chomsky-Foucault debate, and I sort of found a way of addressing that content with chatbots.
Mm-hmm.
After that piece, I started to ask myself, what is interesting to me about this? And I realized at that time that it wasn't so much like the AI, the part of imitating human behavior was not maybe the most interesting. It might be rather this notion of trying to kind of compose theater through, procedures and like in this kind of rules-based way.
Got it. Okay.
So the next piece I made was called A Piece of Work, and it was a version of Hamlet in which I took the kind of text of Hamlet as data and then used different algorithms to scramble or rewrite the play in various ways. And that was my effort to sort of like, what is algorithmic theater? If you wanted to use algorithms to make theater. And we used, slightly more sophisticated techniques than I had in Hello, Hi There, but still very like, symbolic, rules-based kind of stuff. And then I decided I was ready to get into something more sophisticated. So this Yesterday Tomorrow really started with, the algorithm, and then I went in search of a content. I was talking with a friend of mine who's a computer, like an engineer, software developer. And I asked him if he would explain evolutionary algorithms to me. And so we were like just having this phone call where, he was trying to explain how these things work. And I said, more or less misunderstanding them, I have to say, like, oh, I see, you can use them to turn one thing into another. Like you could turn the song yesterday into the song tomorrow. And he said, well, you could try. So we then spent about a month trying and found that an evolutionary algorithm is totally the wrong way to go about that transformation. And it's sort of interesting why. So evolutionary algorithms, and again, Zach can correct me here when I misspeak, but are basically modeling the process of natural selection. So they're like a really simplified version of like a Darwinian survival of the fittest process. And you start out with like a population of different options. Mm-hmm. And then you test which of those, million options are closer to your goal. So they're used when you kind of know where you want to get to and you know where you're starting, but you don't necessarily know the optimal path to get there, which is why I thought it would be cool to transfer.
And just to concretize it for a moment, like the beginning is yesterday and the end is tomorrow.
Right.
Yes. Okay. Got it. Okay.
You have this collection of notes and you have a collection of, syllables that make up the lyrics. And I thought like, well, let's say we know where we're trying to get to. Mm-hmm. And we use this process of natural selection, this sort of, simplified version of natural selection to create enough generations, enough, whatever, to sort of move the music in that direction.
Right.
And what happened when we did this is we got about 30% of the way to our goal. And then the computer was humming along and working and trying to make more possible options that would maybe get us closer to the goal. And it just never got past 32%. And Dylan, the computer programmer I was working with, when he sort of, looked a little bit at what was going on, he said, Annie, like the sun will grow cold in the sky before this program ever makes it to tomorrow. And the reason is because there were so many, trillions of possible musical paths that it was just the amount of processing it would take to like ever make any progress towards getting closer it was just enormous. So, to get 1% of the way closer would have taken, 5 years or something.
Understood. Okay.
I don't know if that's very clear. Maybe Zach can do a better, more succinct encapsulation of evolutionary algorithms, or maybe we don't mind.
Well, I think, Go ahead, Zach.
I'm sorry, I wouldn't speak too much, if only because I mean, among other things, I think I came up at probably the time in like AI research when like evolutionary algorithms were least fashionable and perhaps like you know, successful on problems of like practical interest. Although there's like a few weird areas like hyperparameter optimization where which we don't have to go into what that is, where there still are some popular algorithms, at least in my line of work. Right, at a high level, it's just you need to define some, whatever is the object you're trying to create or the program you're trying to create, you need to have it defined in a like sufficiently sort of flexible way that there exists sort of ways of mutating it such that like what results from a mutation is still somehow like a viable program. And I mean, the key things are like whatever is your language for expressing what this, you know, these objects are that you're searching over, what some model for how mutations happen, and some kind of fitness function that evaluates how good they are. And you know, in some ways, even when we're not using evolutionary algorithms, just when we're building, you know, other kinds of machine learning algorithms like neural networks, some of those aspects are in common in that you are searching over some space of candidate models, you know, and you have to evaluate how good they are, and you're trying to adjust them to make them better and better and better. In the case of evolutionary algorithms, you have this idea of a population and these ideas that are maybe modeled, you know, influenced or inspired by genetics, like this idea of crossing over, like, you know, that there's whole segments of you know, these objects that can be exchanged with each other, like just like chromosomes crossing over from, I don't know.
Suffice to say,
remember a little bit of like 8th grade biology.
Yeah, that,
yeah,
like,
but I can't speak exactly to what's happening there, but I could say just in general that like, you know, a lot hangs on a few things. One is your sort of definition of the fitness function being such that you are able to have meaningful signal to be able to make progress, and you know that can be tricky sometimes.
Yeah. So suffice to say, we didn't use them.
Right.
Like abandoned. That was like a place where the idea that, you know, I like the little lesson I got and how they work gave rise to the idea, and the idea outlasted the technique. So,
understood.
Yeah.
Lovely. Well, and just because we only have 15 minutes left here, this is it's far too brief a time for the topic we're trying to cover here. But instead of sort of going back down into the technical side of this, I guess my question is like, why do this? Like Shakespeare had a whole way of doing theater and people liked that, and then you come along with a bunch of computers and algorithms. Like what are you exploring here, or what are you able to access that the ideas, the themes that you're able to access here that say the sort of more run-of-the-mill playwright or director isn't able to access, Annie? Right.
So I think, you know, there in a way there's like one answer to that, which is sort of questions about theater itself, and then there's an answer to that which is about like what it is what it feels like to be alive right now in the world.
Let's go with number 2 first. Explain that one to me if you would, please.
You know, you were getting at it actually with the way you introduced this talk, that the number of sort of algorithmic processes that we touch every day is really enormous, and some of them we're aware of and some of them we're not aware of, and they increasingly define not only, you know, the, you know, practices of like an enormous number of sort of like professional fields and areas of human endeavor, but they define obviously the way we communicate with each other. And then they define, and this is where I think, you know, things get a little bit more consequential in some ways, is they define what we know about the world, how we learn about what's going on in the world. And I don't just mean our news feeds, but also like, you know, what we think other people think, and what we understand about, you know, all kinds of things. So, you know, we've obviously been having this kind of national or even global conversation about misinformation and disinformation, and social media amplification, and all kinds of things that kind of get at what maybe we all feel as an epistemological crisis, like a crisis in how we know what we know, how we learn about the world, the basis for all the decisions we make in life, and so there's this epistemological crisis. There's also I think, looming crisis about decision-making itself, that we are increasingly handing over responsibility for decision-making to algorithms, what they call algorithmic decision systems. And we are hearing about them very often when they make mistakes. So when an algorithmic decision system incorrectly identifies a suspect in a crime, or incorrectly tanks somebody's credit score, making it impossible for them to get a loan or whatever, like we're hearing about some cases where there's an obvious mistake. Mm-hmm. I've been wondering a lot whether actually we have a decision to make, really. Do we want to make these systems better so they make fewer mistakes? Or do we want to give them less power so the mistakes they make are less consequential? We're obviously spending more energy on the first option. But to my mind, an algorithmic decision-making system that doesn't make mistakes is really pretty scary, actually. So I don't know that putting all of our energies into making a flawless algorithmic decision system is like a great idea for the future of, I don't know, our capacity to govern ourselves, our capacity to purposefully change structures or systems in which we live, to sort of like wrest control of our own destiny. I mean, like the word destiny sounds enormous, but in a way, this is what we're talking about. So,
well, and if I could bring Zach in here real quickly, because you're the technologist amongst the three of us, the person closest to this stuff being made day in and day out. What did those conversations look like in the academy, in the lab?
Sure.
Are the concern Annie's raising the ones that you hear from people at their workbenches?
Yeah, absolutely. So this is actually like one of the major kind of thrusts of research in my lab. Is and I think like a broader emerging theme of research that I guess I've been interested in since early in my PhD, but it's sort of caught a lot of attention recently, is basically I think sort of ML used to be more of an academic concern.
Machine learning, that is.
Yeah, and as this technology has been getting used, suddenly there's I think it's decisions where they're already sort of laden with ethical sort of import. Like it's because they're, suddenly if you're making a decision about who gets credit, how to treat people in a healthcare setting, suddenly you're starting to automate these systems, and you have to that are making decisions that have sort of ethical consequences. You have to think, well, how do I incorporate these concerns in a way that's sort of formal, so that I could specify into the system. So I give an example of how this field kind of started catching a lot of wider attention, becoming a bit more of a sort of just, yeah. So in 2016 or so, there was an investigation by ProPublica, and specifically they were looking at recidivism prediction. So this is basically judges either in like pretrial detention or sentencing or parole decisions. Often like one of the factors that they take into account when making decisions is some notion of like, what is the probability, how likely it is that if we let this person out, that they're going to commit another crime.
Right.
And so the hope that, or at least what's promised by the technologists introducing some, machinery, here is that, if we use some algorithm to assess these risk scores, they call them like risk assessment instruments, that maybe we can make decisions that are sort of more accurate, and maybe in some sense that don't have the biases that human judges have. So this is the hope for panacea, is that these are somehow more efficient and we can incarcerate less people and yet have less crimes committed. But the problem is the way that you actually build such an instrument. And I think the recurring theme through all of this is basically that we have a lot of these very thorny issues where it's not quite clear what is the right thing to do, but we need to build some technology where the way we train such a system is we explicitly say, here's a context and this is the right thing to do. And so what we often fall back on is just trying to predict what was done historically, or try to predict, what some target that we think is a proxy for the decision that we care about. So in the case of criminal recidivism, sorry, Herbie is a little bit irritable. What they might do is they say, oh, here's a bunch of characteristics of some defendant who was released on bail historically, and now we observed, were they or were they not, subsequently rearrested within 1 year of release or something like that. And you have this for a lot of people who were released, and so now you basically train a model whose job is to try to predict what's the probability of rearrest, given what I know about this person. And they throw in a bunch of factors, whatever's available. What's your occupation? How many prior offenses? How many years of education? How many siblings did you have? Some of these features may seem relevant for making some kind of procedurally just determination. Some actually seem like maybe why should you be punished or not, depending upon some of these factors. And so, all kinds of things can go wrong there, right? Because the thing that you're trying to imitate is, for example, in this case, rearrest. If it so happens, for example, that what you really care about, what's the probability that someone will reoffend, but what you observe is where they rearrested. And rearrest is something that depended in part upon patterns of policing. And so if it so happens that police more heavily sort of patrol Black neighborhoods than white neighborhoods, and therefore offenders on account of being Black are more likely to live in a neighborhood where they're more likely to be caught, then suddenly you're training to try to predict something where there's multiple ways to predict it. One is try to predict that they'll commit a crime, but the other is try to predict find features that are predictive of them being arrested given that they committed the crime. And these might not be things that actually people should be sort of punished for. It's just, and so there's lots of examples of these kinds of situations where, ultimately you're trying to build a system that makes some kind of complicated decision, but we don't know how to actually tackle that head on. What we know how to do is build a prediction machine. And what we feed into it is a bunch of historical data, often where the target variable is some sort of crude proxy for what we actually care about. And we're left in this weird situation where, we don't even know how to evaluate the system, let alone, to optimize it. And with this imperfect technology, and then the sort of debate ends up being something like, how bad is this technology, and who is it harming, and how do we even know? And then the sort of related debate, which is, however bad it is it worse or better than the status quo? And they're both hard to answer, but they're sort of fundamental questions that if we're going to have this technology sort of laden throughout right now, for example, how people get hired. I think there's some frighteningly large percentage of job applications that go through automated resume screening. Certainly. Or how carceral decisions are made, or how healthcare decisions are made about who to prioritize for higher levels of care. Then we sort of have to figure out how do we incorporate sort of normative principles into the design of technical systems. And I think that's this weird, exciting, but also confused and dangerous area where, we find ourselves.
Well, to that, Annie, I guess there are obviously a host of possible futures and concerns that one could have about those possible futures because of this technology. But tell me a bit about your future, if you would. What's on the what's kicking around your head? What's currently in the works? What can we look forward to?
Right. So a lot of these questions that Zach is raising, I've been, spending the last several months trying to kind of figure out what my response is to those questions, and also to some of the new predictive technologies that I've been playing around with. So a lot of people have been talking about GPT-3, which is the sort of newest version of a text generation algorithm.
And you mean like the type of thing that if you're emailing, it's finishing your sentence for you, that type of thing?
Yeah, that kind of thing. GPT-3 can do a lot more. It can do a lot more.
Okay.
So it can, in one application, it can, you give it a little prompt of a few phrases or something of writing and ask it to finish the piece of writing that you started. So you could, you know, give it like, oh, yesterday the weirdest thing happened to me. There was this guy at the grocery store, and, you know, and this algorithm will tell a story about some guy at a grocery store. And it, you know, will even try to kind of match some of the voice of the writing. So if you give it a prompt that uses technical language, it will continue in that vein with a lot of technical language. If you give it something really casual and slangy, it will try to match that voice. Some of the writing that it produces is incredibly plausible as human writing.
I could give the like 1 second sort of version of what this is, which is literally, it's like when I was describing the translation systems before, it's exactly like that, but you remove this idea of like, there was the input sentence. So it's literally just, what they do is they crawl all the text they can off, say, the internet, or every single article that was ever linked to from any Reddit post ever, or something like this. They built some absolutely enormous corpus of text. And it's some really powerful neural network model, just a very flexible predictive model. And all it does is it says, you feed in a word and you should try to predict what's the next word. Then you feed in what was the actual next word, and given, you know, the entire history, it tries to predict what's the word after that. You know, given the third word, try to predict what's the fourth word. So it's just looking at a context and trying to predict what word comes next. Or, you know, it's a little bit more complicated. It's actually something called a word piece, which is something that's between a letter and a whole word, but don't worry about that. And so that's all that it is. But it's trained on, let's say, something close to like all the text on the internet. So it's learned to be really good at guessing the continuation from any sort of previous context. Given the previous 1,000 words, guess what comes next. And if you just start feeding its own predictions into itself, you know, now you have new text that wasn't necessarily there before. And so when Annie talks about a prompt, it's basically saying, well, you have this system that was trained on billions of documents to always be able to predict, you know, with reasonably well statistically what word comes next. And so if you feed in something that seems like a plausible prompt, it's going to be good at guessing what should follow. So it wasn't trained with any particular objective at being good at this application versus that application. But, you know, if you figure across the entire internet, it's seen movie reviews, it's seen Wikipedia articles, it's seen whatever. So you could write something that looks like the beginning of a Wikipedia article for a fictional species that doesn't actually exist. And it's just going to start continuing in the style of a Wikipedia article, writing things that, you know, look like it's describing. And they could look often really stylistically great, but if you look at what it's actually writing, sometimes you find something bizarre. Like you might have a Wikipedia article for, you know, a cat that describes a cat as a species that has 4 hearts and 3 kidneys and whatever, but all the text, you know, seems like it makes sense. It could be something if there was such a, you know, if the facts were right.
Well, and so Annie, and we're all but out of time here. Any peek into your brain as to how you're thinking about responding to all this? Yeah.
I mean, I'm starting in a very straightforward way. I'm not comfortable actually yet, I don't think, with like my artistic response to these tools. One of the things that you know, is a tough problem for me with them is that they supply so much. There's not a lot of gap. They don't leave a lot of room in a way for the audience's imagination to fill in, like we were talking about the Eliza effect. That effect is most powerful when the audience actually has to do some work to like fill in what's missing from, you know, what they're getting. And some of the, you know, like more sophisticated machine learning, like generated material, it's too good in a way. It does so much that I don't know exactly how to situate it in a way that I find interesting. But I'll tell you what I'm going to do, which is maybe sort of, which is kind of fun to hear about, I think. And I don't know if it will turn out well. It's a first stab at something. There's a Aeschylus, the Greek. I've been really interested in Greek tragedy lately, so for a whole bunch of reasons we don't have time to go into. But he always wrote in trilogies, and so we know this play Prometheus Bound, but actually there was a trilogy. There was Prometheus Bound, Prometheus Unbound, and Prometheus Firebringer. Prometheus Firebringer, there's only one line that still remains, and it's like there's this like single line of whatever the play was. The rest of it's lost. So I want to use GPT-3, or maybe by the time I get to it, we'll be on GPT-4. I don't know, to fill in the missing play.
Wow.
And we're going to experiment with different ways to sort of tune that text generation model to give us different kinds of options for what the rest of that play might have looked like, either historically, or maybe we're going to do some really off the wall kind of bananas things with it. But using this notion of Prometheus, a play about, you know, from one perspective, a play about the promise and dangers of techne, of human craft, intelligence, and technology, to sort of explore what this imitation of human writing looks like and what it might do.
Well, we will all be anticipatingly staying tuned. Annie, Zach, thank you both so much for doing this. Thank you everybody, all of the faceless, nameless participants that we've been told are looking back at us. Thank you all for coming. Thank you to Aaron and Carol Mack for their generous support for making this happen. And again, thank you all for coming, and enjoy the insides of your apartments as we continue to social distance and stay safe. All right. Thank you, folks.